Hi, I'm Luca Congedo and you're watching From GIS to Remote Sensing. This is the second tutorial about the use of the semi-automatic classification plugin for the classification of Landsat images. In particular, we are going to use the tools of the plugin for downloading and processing the images, and we are going to create a land cover classification identifying the following land cover classes: water, built-up, vegetation and bare soil. Okay, so the first step of this tutorial is to download the Landsat images. The semi-automatic classification plugin has a tool for downloading Landsat images. In particular, you can reach this tool by clicking here, the Tools button. And also I want to show you that you can reach the functions of the plugin from here. As you can see, there are a menu for all the functions of the plugin, and you can download Landsat from here. But before downloading the database, it is useful to select a database directory, because otherwise the database is downloaded inside the plugin directory. So if you update the plugin, the database will be deleted. So we select a database directory and we save it in the user directory, for example. So we say LandsatDB and we click OK. So now that we have set the database directory, we can update the database. We check to update only Landsat 8 because we are downloading a Landsat 8 image, but of course you can download also the Landsat 4, 5 and 7 databases, and of course this will require more time. So now we click Update Database. We click Yes to this question, and of course we need an internet connection. And as you can see, the tool is downloading the database, the Landsat 8 database. Okay, so after a few seconds, depending on your internet connection speed, we have downloaded the Landsat 8 database. Now we need to search for our image. The tool allows for searching for date, for cloud cover, for image ID, and of course we can also search geographically using the coordinates. In this particular tutorial we are going to identify the image through the Landsat ID, but of course in other tutorials I'm going to show in more detail all the tools for downloading Landsat images. So if we go to the tutorial web page, we can copy and paste the Landsat image ID that we need for this tutorial. The Landsat ID is this one. We can copy and paste it in the semi-automatic classification plugin here, in the image ID. And we can click Find Images. After a few seconds, the tool has found the image that we can also display in QGIS. Clicking here, Display Image Preview. Here in QGIS, as you can see, we have a preview of the Landsat image. Of course, this is a very low resolution preview, but you can see, for instance, if there are clouds in your area of interest, so it is very useful. So if this is the image that we want, we can start the download. But first we need to select the bands that we need. In particular, we need just band from 2 to 7, so we uncheck all the other Landsat bands. So Now we can download the image, but first we should uncheck these options. Click Download Images from List. Then we select the directory for downloading the image, and now we select the desktop. Here in QGIS you'll see the download progress. Of course, this will require a few minutes depending on your internet connection, because as you can see, each Landsat 8 band is about 50 megabytes. So after a few minutes, as you can see, the tool is downloading all the Landsat 8 bands. And when the download is finished, as you can hear, a sound will inform you that all the Landsat 8 bands are downloaded. And if we open the directory, as you can see, a new directory is created with the same name of the Landsat ID, and inside this directory you can see that there are all the Landsat 8 bands and the metadata file that is useful for processing the Landsat image, in particular for the conversion from digital number to reflectance. But we are not loading these Landsat 8 bands in QGIS because we need to perform the conversion to reflectance first. So in QGIS we can remove, this is the preview that we have loaded before, we can remove this. Then we need the preprocessing tool of the plugin. Here in the Landsat preprocessing tool we can select the directory where the Landsat bands were downloaded, so this one, which is the same name of the Landsat ID. As you can see, automatically the plugin has loaded all the parameters from the metadata file, and we don't need to edit these items. And in particular we need to check this checkbox, apply DOS1 atmospheric correction, which is a particular atmospheric correction which is image based. And now we also uncheck this checkbox, create band set, because I want to show you how to create a band set manually. But of course, if you leave this checkbox, you will automatically have a band set created here. But we are going to come back to this later. So checking apply DOS1 atmospheric corrections, click the button Perform Conversion. Then we select where to save the bands converted to reflectance. Here we can create a directory here, for instance, and click OK. So the process of conversion will start, and of course it can last a few minutes because we are converting the whole Landsat band one by one, and also applying this atmospheric correction. So again, the sound of the plugin informs us that the process has completed, and the bands, Landsat 8 bands converted to surface reflectance using the DOS1 correction are automatically loaded in QGIS. So in this tutorial we are going to classify only a small subset of the Landsat image. So the next step is to clip the Landsat 8 bands. In order to clip these Landsat 8 bands for our study area, we need to use a shapefile. So you can download the shapefile of the study area from the website of the user manual. From here, click and download the shapefile. Now we are going to extract the zip file and open the shapefile in QGIS. So now we need to open the tools, the clip tool of the plugin. If we go to the tool Clip Multiple Rasters, we need to click the button Refresh List so we can see all the Landsat data bands converted to reflectance. Click Select All because we need to clip all the Landsat bands. Then we check this checkbox Use Shapefile for Clipping, and we also need to click Refresh List here because here we can see the study area shapefile. This way we are going to clip all the Landsat bands using this shapefile and save the clipped rasters in a new directory. And we click OK. So, as you can hear, the process of clipping is completed, and all the Landsat bands are loaded in QGIS. If we zoom, we can see that all the Landsat data bands clipped as this prefix clip, and we can load the Landsat 8, the original Landsat 8 bands from QGIS. So now we have the Landsat bands clipped for our study area, and the next step is to create the band set so that the plugin can use these bands as input for the classification. In the previous tutorial we have used a single multispectral raster, while in this tutorial we have separate bands. So in order to create the band set, we click here, the band set tool, and we need to add all these bands to the band set definition. So we click Select All and click Add the Raster to Set. As you can see, all the bands are loaded in the band set definition. We need to define the center wavelength here, and of course if the order of the bands is wrong, we could just arrange the order using these arrows. So now we need to set the center wavelength for each band, and we can use, because this is a Landsat 8 band, we can use the quick wavelength settings from here and select Landsat 8, and automatically each center wavelength is loaded for each Landsat band. So now that we have defined a band set here, we can see that a band set is defined as input image. So now we need to set the input training shapefile and the input signature list file of the plugin. In the previous tutorial I have shown you how to create a new shapefile, a new training shapefile, and a new signature list file. In this tutorial I want to show you how to load the previously saved training shapefile and the previously created signature list file. For the training shapefile we need to load the shapefile with QGIS. So now that we have loaded the training shapefile here in QGIS, we must click this button Refresh List here and select, of course we have just this training shapefile loaded in QGIS, and as you can see, automatically all the regions of interest that are inside this training shapefile, if we open the attribute table here, we can see that the same regions of interest are loaded in the row list here. For the signature list file, we need to open the signature file XML that I've saved here. So if we open this, we can see that all the signatures are loaded in the signature list. So now we need to create the region of interest. In this tutorial we are going to find 4 macro classes: water with the macro class ID 1, the tap with the macro class ID 2, vegetation with the macro class ID 3, and bare soil with the macro class ID 4. And later I'll show you the difference between classes and macro classes and how it can be useful for the classification process. But now we are going back to QGIS, and we can select the color composite of our image. In the previous tutorial I've already shown how to create a color composite of a Landsat image. Here, as you can see, as I have selected a RGB color composite, a virtual raster is automatically created and loaded in QGIS. So this virtual raster is created for this bandset. This is a temporary raster, so when you close the QGIS project, this will be deleted. And as you can see, we can select one of these RGB color composite, but we can also create new color composite here by writing here the expression of the color composite. So for instance, we can create the 3, 4, 6 color composite and press enter. And here this new color composite is added to the RGB list, and we can quickly switch between the color composite with the mouse wheel over this list. So it is very useful for highlighting the features in the image very quickly. And in particular, this color composite 346 is very useful for highlighting urban areas. As you can see, urban areas with this color composite are colored purple, while this color composite 432 is particularly useful for highlighting vegetation. So switching this color composite allows for a better discrimination of materials at the ground. And another plugin that could be useful in this step of creation of regions of interest is the Open Layers plugin. If you install this useful plugin, you could add to the QGIS project one or more of these layers, high-resolution layers. For instance, now I'm adding the OpenStreetMap layer. So it can be useful for identifying features in the high-resolution map that we cannot identify clearly in the Landsat image. So it is important to identify every material at the ground. So for instance, large buildings, as you can see in this image, or roads, as you can see in this other image. As you can see, the color composites are very useful for discriminating these features in the image. For instance, the roads are not particularly visible in the RGB 321, while they are very visible in the RGB 432 and especially RGB 346. We can also identify small buildings and narrow roads, which, as you can see, the pattern is different from large buildings. We can also identify bare soil, for instance this uncultivated land, which in the RGB 321 is brown, while in the RGB 432 it is particularly different from cultivated land, which is red in this color composite. As you can see, the RGB 432 is particularly useful for identifying crops and healthy vegetation. And as you can see, as I have clicked over the recreation tool, a number is displayed over the cursor. This number is representative of the NDVI, which is the Normalized Difference Vegetation Index. And as you can see, this number is higher over vegetation and is lower over built-up areas or bare soil. So it is lower where there is no vegetation. So in combination with the color composite and this value displayed over the image, we can easily identify if a pixel is vegetated or not. And we can click and quickly create regions of interest. So for instance, if we see that the NDVI is very low, probably this is a built-up area. So for instance, if we click here and we create a region of interest here and we increase the range radius value a little, we can click the redo button and the new region of interest is created with this new parameter. If we increase the value a little more, we click the redo button here, we can see that the region of interest is becoming larger. So let's say that we are satisfied with this region of interest, so we select here our macro class ID. This is grassland mainly, so the macro class is vegetation, and as class ID we need to set a class ID that is different from the previously saved regions of interest. So we need to set here 5, and we can write here, for instance, grassland. Now we can save the region of interest. As you can see, a new region is loaded in the array list, and a new spectral signature is calculated here in the signature list. We can see, for instance, the spectral signature of this region of interest by clicking this button here. As you can see, there is a very high value here, which is in the near infrared because it is vegetation. We can also compare this spectral signature with another spectral signature already loaded in the signature list, for instance this other one of vegetation, and we can see, we click here fit plot to data, that there is a difference in the values because this previously saved spectral signature was calculated without the definition of the central wavelength of the Landsat band. So what we need to do is to remove these 4 spectral signatures already loaded because the values are not compatible with the new spectral signatures. For instance, if we see the signature details, we can see that the values of the new spectral signature are decimal values, here all lower than 1, while the values of the previously saved spectral signatures are in the order of thousands. So we need to remove with this button the spectral signatures here. Of course, we can calculate the spectral signatures that we have removed again using this button, Add to Signature. So if we click here, the process starts calculating the spectral signatures. Of course, we need to set the colors of the classes again. But now, if we compare the vegetation and these other vegetation spectral signatures, we can see now that the values are compatible. We can remove the two spectral signatures from here, and now we can see that the spectral signatures are very similar. So now we can change the color here. We can assign new colors to the vegetation, to water, and so on. And another useful feature of the plugin is that you can zoom to the region of interest by double-clicking the row list. So for instance, if we double-click the water region, here we have zoomed directly to the saved region of interest. If we double-click over here, the built-up region, we can zoom directly to this region of interest. So now we need to create several regions of interest. Now we have only 5 regions, but we need to create a region of interest for every material at the ground. The more regions are created, the better. This is because the classification algorithm will identify the similarity between the spectral signatures loaded here and the spectral signatures of individual pixels here. So for instance, if we want to display the spectral signature of a pixel, for instance a pixel here, we just right-click over a pixel and a new spectral signature is calculated here with the macroclass information pixel, and the color here is orange. So we can see that this particular pixel has a very low spectral signature. If we click over a pixel that has a very high value of normalized difference vegetation index, for instance here with 0.72, if we right click here, we can see that a new pixel is loaded in the spectral signature. Now maybe we should change the color in order to display it better, and we can see that it is very similar to the spectral signature of vegetation that we have already collected, so we don't need to create a new region of interest here. So we need to create more region of interest, for instance for the built-up areas, so we can zoom over this area and we can see that this line is a large rod, and we can switch the color composite so we can see the rods better, and we can create a new region of interest here. So click the recreation tool and click when we see a very low NDVI value, we are probably over this built-up area. So we click here, and as you can see, a new region of interest which is following the rod is created, and now we can add the region of interest to the array list. So the macro class for built up is 2. you can see that if we have already created some region of interest, in the macroclass information here, as I start typing the B of built up, we have the list of macroclasses that we have already digitized, so I can simply click here, built up. So it is a sort of autocomplete, which can ease the process of creation of rows. Now I need to increase the class ID, but I'm not doing it because I want to show you also how to edit a region of interest that it is already saved. So for instance, here I write rod and I save it here. So for instance, if I have not set a proper class ID here, I can edit the row list directly. So just click over the class ID and I can increase the value, so now it is correct. I can do the same for the class ID in the signature list. So I click here over class ID and I can increase the value. Of course, I can also change the class information with a click and, for instance, say rod 1. And every change in the region of interest list here, it is also reported in the training shapefile. So now that we have created several regions of interest, we can create a classification preview, which is a way to assess the quality of our spectral signatures, in particular if we have identified all the materials at the ground. So here we can set the classification preview size. We can say 500, this is the unit in pixels, and we can click here activate preview pointer. With a left click over the image, we can see the classification preview using this algorithm. Now we have used the minimum distance, but we are going to use the spectral angle mapping algorithm for the classification. So we change the algorithm here and we can click the redo button here, and as you can see, the classification preview is updated. Classification previews are temporary rasters that are loaded in QGIS in this group, class temp group, and all these rasters are deleted after the QGIS project is closed. So we can see, for instance, that we have classified quite correctly the vegetation, but we can see that we have classified as built up also this area here, which is probably not built up because it is quite dark. It is an area in shadow, so we need to create a region of interest over here, and we can set, for instance, as vegetation macroclass, and we can set here trees in shadow, and we can say the region of interest and calculate the spectral signature here. Now we change the color again, and we can redo the classification preview. It is important that the creation of rows and the calculation of spectral signatures is an iterative process. So after the creation of a region of interest, it is important to evaluate the results, creating a classification preview. So we click the redo button here. So as you can see, the area that was previously classified as built up is now classified as vegetation. And if we move over the image, we can create other classification previews and see if the image is correctly classified. Now I have classified the image, the preview, using the spectral angle mapping and using the class ID. This is because I have not checked this checkbox, use macro class ID. If I check this checkbox, I'm going to classify the image using the spectral signatures here, but the classification results will be classified as macro classes. So if I click redo, as you can see, the colors here are, as you can see in the layers, the new classification is classified with only with macro classes. And although the spectral signatures are the same, we can see that the results are different. If we switch between the classification preview using macro classes and classification preview using classes, we can see that, for instance, the built-up area is classified as built-up here, while in this classification we have a difference between buildings and roads. So here you can see that several pixels are classified as water because I have erroneously set a macro class ID 1, which is the macro class for water. So now what I need to do is to edit here the macro class ID and set the vegetation macro class ID, which is 3, and the same for the spectral signatures. And click redo. And now we can see that the pixels are correctly classified. This is to show you that you can easily change the macro class ID and information for rows or for signatures directly in the region of interest list and in the spectral signature list. And now we can compare the preview results, for instance, with the high resolution data. I've previously loaded our OpenStreetMap here. So using this button, show and hide, we can quickly identify if we have classified correctly urban areas or vegetation. And we can also see how each spectral signature affects the classification results. For instance, if we enable or disable a spectral signature here, for instance, we can disable the spectral signature of built-up the roads. We can click the redo button here. We can see that the classification is different. For instance, if we also check bare soil, we can see that all the pixels classified as bare soil are now classified as vegetation. And of course, now we are going to check all the spectral signatures here and perform another preview. And so let's say that we are satisfied with the classification preview. Now we can create our classification for the entire image. So we click here the button Perform Classification. We select a directory and we can create a new raster and we click Save. And after a few seconds, as you can hear, a sound informs us that the classification for the whole image is completed. Again, we can check the results with our high-resolution data and see if there are areas that are not classified correctly. So well done, we have completed our second tutorial Of course, we would need several regions of interest for accurate land cover classification. Well, that's all for this edition. If you have any questions or comments, please join the Facebook group or the Google Plus community of the semi-automatic classification plugin for QGIS. Thank you for watching.